Hi, thanks for that. Sorry about that. My computer just crashed, so I was having a little bit of an issue recording. Hopefully, I can just pick up where I was. I recognize that I've been going on for about an hour now. It's probably getting a bit long-winded. Take a break if you like. Obviously, pause, come back to this at any point. Watch it at double speed, or don't watch it at all. Whatever you want to do. But um, I was just touching on this idea that the gypsum wall sheathing type, these unadjusted lengths can be halved, and the way they can be halved is by installing the gypsum sheathing framing or gypsum sheathing in a prescribed fashion on both sides of a wall, and then we can halve the lengths. And the calculator reflects this as well. So I'll jump over here. Where would it be? So it's an option for designers when you come to the design and feedback tab to have, if we're looking at the reference framing types, to have what I'm calling like the reference framing type dash A, dash 2. That's just to represent that it's gypsum that is doubled up. So we're one on one side of the wall and one on the other side of the wall. Hopefully that's pretty clear for users. So basically it just changes the values that are being pulled back into the code. There are some complications to this, though, that aren't, in my opinion, very well defined. One of them is that so the code says that basically, looking at this bracing into the roof system, that if you have a wall reference type that is WSPB or more heavy duty, for example, so this or greater, then it is required to be braced into the roof system. My understanding of this is that it's based on the level of resistance, like per lineal foot or per meter, that brace panel is providing, and the requirement stems from the fact that if you have this as like an interior band, for example, and your WSPB is an interior band, because the amount of force that panel is resisting per lineal foot cannot be adequately transferred into the roof system by the presumed drywall on the ceiling. When you are selecting one of these other ones, WSPA or lighter, for example, it is assumed that the drywall is providing enough resistance to transfer the forces into the roof system. Now, what's a little bit confusing in my mind, a little bit tricky in my mind, is when we take, let's pick another one here. Let's say GWBC, and I'm kind of alluding to it here, but GWBC is a drywall-based panel, and the code says that panel is not required to, because the drywall base is not required to for that bracing to continue into the roof system. However, when we double up the panel, in my mind, we are essentially doubling or increasing the amount of resisting force that we are providing in a panel per lineal foot or per lineal dimension. And so what I've tried to do and what I've assumed through the calculator is that some of these GWB -2 elements, reference framing types, actually are required to transfer an amount of bracing force per lineal foot greater than WSPA. And so this would be one example of that. And so that's why in my calculator, this comes back as required. Now, this isn't really called out in the code. And again, it's another point that I'd be curious to see what others think about this. But the sort of assumptions that I've made are that if we're relying on this to provide twice the bracing amount, we should be considering it not necessarily just as a drywall-based panel, but something that is stronger. The same sort of concept applies when we're thinking of things like the connections. So like maybe particularly like the anchor bolts, for example. There's not too many. I guess you could have like an interior drywall panel that is anchored to a foundation on the interior of a basement or something like that, where you'd be considering the spacing of anchor bolts. And again, that's something that relies on the um, how much force per lineal foot that panel is resisting. So some questions around that regarding sort of whether this is an adequate way to represent that through the calculator. I don't know. In my mind, what I've done here is actually more sort of conservative in its approach. I've been more concerned for a regulator, for example, if these types of panels, these GWB -2, if these types of panels were not required to provide that bracing into the roof system. So, I mean, and to go on a little bit further, just to say that the representation of this list, therefore, is not necessarily accurate in terms of like least resisting reference type all the way up into most resisting reference type. There's some, it's generally that way, but by including these 4 here, it's sort of muddied the waters a bit there. I mean, these would and the way that I've developed it in terms of the bracing to the roof system, these actually distribute between these a little bit and a little bit into the wood sheaths panel. And then I just take that same threshold as WSPA as being the sort of cutoff point to panel types that are not required to have the bracing of the roof system. Anyway, a little bit of the back end information behind there. Okay. While we're just looking at compliance and calculations, I wanted to look at this tab, the adjustment factors matrix. I've touched on this before about the adjustment factors in one of the previous reports. This idea that 1 is, like if the factor is 1, it essentially references what is probably the reference type of house that was used for the development of these prescriptive requirements. If a factor comes back at less than 1, we're getting sort of some bonus. If it comes back as more than 1, we're going to be paying a penalty against that reference house. This is just a bit of a visual representation of that. It lists all the different adjustment factors for wind, all of them for seismic factors. I could possibly build this out to include the coefficients as well, although they sort of work their way into the calculations a little bit differently. But here you can see sort of a little bit clearly on how these adjustment factors are applying to each story, and if they're applying, obviously with our building we only have 1 floor that is required to have bracing. It's going to be the roof floor, which would be this column, and then this column, and it's just showing how some of those values in our table, which was this table, the adjusted lengths table, looks like this. So for example, how do some of these values get determined? Because in the code sometimes there's multiple sort of calculations that are required to come to a specific number. Anyway, so I've tried to visually represent that through there. It's just part of the computer logic. It might be helpful for users to be able to see some of this information and how it's happening. It may not. I don't know. It was certainly helpful to build it. I'm going to jump into these construction reports, or what I'm calling the construction reports. I go over these in a fair bit of detail in the other demo video. I have certainly some questions about this and whether the things that I'm doing are appropriate for the building code. A lot of this information on these reports relates to the types of fasteners that are used, and specifically the nails that are used. When you're looking at part 9, there, what am I trying to say? The way that nailing is referenced in part 9 seems to be, I mean, it all turns out into metric, but it seems to be that the nail references in terms of the length reference through to a nail diameter, and that nail diameter, to my understanding, is typically based on common hand nails. Common hand nails, generally speaking, are usually in terms of framing, are usually a heavier gauge or a heavier diameter to nails that might be typically used by framers who are using pneumatic nailers or something like that, or even other, I don't know, pneumatic nailers, I guess is the best way to put that. So there are a bunch of different diameters that are available for pneumatic nailers, and the code provides some guidance on how we could use a different diameter nail to meet the requirements of the number of nails and the spacing of nails as it's referenced in the code. So what I've tried to do here is to provide an option for the user to select a type of nail that they'll be using, and then use the appendix calculations to adjust the values that are provided in the building code. When I'm reviewing the appendix for the different permitted methods for determining alternative nailing sizes, I find it quite confusing. Some of the references between different tables doesn't really make sense to me. Some of the references in the appendix talk about like framing nails. Some of them talk about panel nailing, so like for brace wall panels. And then sometimes the appendix references adjustments for nails for framing, but then it also references a table that includes the spacing for fasteners on sheathing. So it's a bit of a mess to my understanding, and I'd love help on sort of clarifying some of those things. So I'm not sure that this is completely appropriate, and those with a technical understanding of how that's working, I'd love to hear input. But basically, I mean, the functionality here is hopefully pretty straightforward and pretty clear. I've tried to provide a selection of nails that are typically available for pneumatic nailers, so strip nailers and coil nailers. The most important reference is to do with the diameter here. So in the back end of the calculator, this diameter gets converted to a metric amount, and then it gets compared to the metric code requirement, and then the reduced diameter, if it is reduced, through the formulas in the appendix, get adjusted to change the amount that is required. So for example, so this reference here is the reference for the common nail that is referenced in the code. Right, so you can see it's a 1.44 or 0.114 of an inch. Right, so if we put that in for our framing nail connections, this here, I'll have a look at that. I think that should be 6, but it might just be a bit of a calculation thing. This is pulling back the values that are actually in the building code tables. Admittedly, just looking at this, like this is meant to be 6 instead of 5 7/8. Anyway, I'll look at that. There's probably just a minor calculation error that's happening. But these are the code references that are in the table. But as you can see, that is based on a nail of this size. If you review most nails on site or available in Home Depot or wherever it might be, you're probably not going to see many strip nails or coil nails of this dimension. Instead, you're going to see these sorts of values. And the ones that I'm probably most familiar with is this diameter, unless something specifically provided for brace wall panel nailing or shear wall nailing. So I put this one in here, and you can see it's a reduced diameter nail, And if we put it in and make that selection, it comes through here. But there is like a significant adjustment to the spacing and the number of nails that are required for those connections. Yeah, I don't know how much people are regulating for this, or how much of a real factor it would be, but or even if the logic that I'm using here to make these adjustments is even appropriate. I feel pretty confident that it is appropriate for these framing nails, but as we move into like the wall sheathing types, I have some questions about it for sure. I mean, the logic and the idea is sound, to my understanding, because when we're looking at like a brace wall panel sheathing nail, the larger the diameter that is called out or used is going to provide like a larger like shear resistance, and so it makes common sense, I think, but like I don't know if it's accurate in the way that it's described in the code. Anyway, so take a look through here. There may be other options. These framing connections here are directly from the building code. There may be other ways to produce, other connections that are in the code. I just sort of picked out the ones that I thought were most appropriate to lateral bracing systems. But it may be helpful for builders to have, more of this sort of automation happening for their connections for their frames. This is all pretty self-explanatory, I think, and hope. Let people go through that themselves. Well, I'll probably just say that there's this little section here for required and not required, and the factors for that are based on the hourly wind pressure. In some circumstances where you have a high hourly wind pressure, there are additional requirements for nailing in the roof sheathing anyway, and that gets converted through here by making this selection. I can probably automate this so that the user doesn't have to put the input, which might be an easier way to do it. If you're reviewing this as a builder, it'd be great to hear sort of whether the way that this information, or as a framer I should say, if the way this information is displayed is useful to you. I think it would probably be useful for building officials reviewing things on site, because there's no way that anyone can ever remember all of these things or perform these calculations in their head or anything like that. There's a lot of variables to this data. Onto the second construction report. This one, as I say in the previous demo, is primarily concerned with the brace wall panel sheathing and the nailing of that sheathing, or the fastening of that sheathing, but there's also a little bit of information that directly relates to the band. So it's sort of at the front end here more so. Again, there's a lot of information that's coming through from the calculator. I'll change this to required. Oops. There's a lot of information that's coming back from the calculator based on these inputs here. So for example, like the double top plate nailing, it's sort of like its own little section of the code, and requires like some significant calculations, which are all in the back here if you want to have a look at them, to check them, to sort of come up with these results. But I think it's probably easiest to display them like this. Something that I definitely have considered is that it would be great, so it'd be possible to work into the logic that if we're looking at max stud spacing, something that might be helpful for a builder is if this calculator calls out the minimum stud spacing. It might just be easier for people to frame all of their walls on the same on-center spacing than be checking this, for example. So that would be pretty easy to do. One thing that I do recognize is that There are other, like in any of this stuff that I'm going through, really, there are other provisions in Part 9 that may influence some of this. So say, for example, it's not going to happen here, but say, for example, you have a larger building and you have cripple walls that are supporting 3 floors or something like that. This maximum stud spacing is going to, it might be calling something out here based on the bracing requirements, but there are other Part 9 requirements that could potentially produce like a on-center spacing of 12 inches, for example. So I am working on producing some of that logic into here. So for example, like with that example I gave with the cripple wall supporting a number of stories, instead of reflecting what is required for the bracing, we would we'd input information that produced like the most restrictive circumstance, and that might be helpful because you might be a builder and build something according to this table, but so it turns out that there's another clause somewhere that actually means you've done it incorrectly. One thing that I would like to change is that some of this information, for example, we have our maximum stud spacing is coming back at 2416, for example. I mean, we all understand that means 24 inches and 16 inches, but back here, for example, it's like 8 feet in inches. So I want to do some work to standardize the way that the numbers are presented, especially when we start to get to like the on-center spacing. But yeah, again, happy to hear any thoughts on different things that could be included in this this report. I do go through it, in something from the other demo, so maybe that'd be helpful to review if you haven't seen it already. So I'm just going to take a quick look through here, see if I haven't really addressed anything. We've talked about this at length in the demo. There may be like a number of different other columns that we could add here. There are a lot of different trigger points that are sort of interest to people designing lateral bracing systems. These ones are the sort of the primary ones to determine the validity of these approaches. But there could be other information that's helpful. You can see I've pulled it out of the main page, but some of this stuff could be helpful as well, especially as we get into heavy construction and things like that. Unadjusted lengths we talked about. The adjustment factors we spoke about. This is all just back-end stuff that obviously isn't formatted, but a lot of the other tables are linking to this information. So it is possible for me to change this source information. This is part of the build out for when the calculator provides calculations for basement and crawl spaces that are not required to be designed to as a story for bracing. The demo that I'm going to, or the test calculator that I'm going to send out won't have the ability to do that just yet. And now we're getting into the BCBC references. Again, it requires some formatting and stuff. I'm not all there yet, but this stuff really isn't necessary for users. A lot of my notes and things are in here to help understand sort of how we got to one point. And so, as some of the feedback comes back from the testers, I'll be potentially making some changes on the back end here and just confirming some different things. It's my hope that we will be able to add references to different tables, to different sheets, or to the README file. So this is just me making a list of them. This is the BCBC adjustment factors for the alternative method of calculation. Again, just putting it into ways that the calculator can understand. the base tables for unadjusted lengths. Again, none of this is required for users. I think most of that information has been transported into the calculator and queried from these things, but there is, there's quite a bit of work that goes into taking the tables in the code and converting them into a way that the computer logic can understand. So this is part of that effort. Again, the unadjusted lengths for wind, the same kind of approach. These ones here that I've highlighted as red and in the middle here relate to the values that are assigned to when we're doubling up the gypsum wallboard. And through my calculations, I was assuming that these 3 reference framing types were also required to transfer through to the roof. I think I noted that that these are actually different for wind than they are for seismic based on the numbers. But again, it feels like it's a bit of a conservative adjustment. So I'm pretty comfortable with it. But if anyone wants to chat about that or has good information about the intention behind those code contents in those code comments about doubling it up and framing into the roof, then it'd be great to hear, to get some clarity on the logic here. Again, just more back-end reports related to the sheathing requirements. As I said before, to me, it's not really that clear to understand how alternative nail diameter nails can be used. Maybe others have input on that. So here, this one actually is probably going to be pretty useful to people. So, or to some specific people, it may be essential to them. So this is a copy of the BCBC, and I guess shout out to the code writers. I think like a lot of the information that I'm using here is all on the heels of their work. I have some questions about it, but I generally think that it's a pretty amazing system that they've developed, and I really hope that people embrace the adoption. I think there's a lot of option, especially for people that are interested. I mean, there's a lot of option available to builders and designers. So something that does come up certainly is that in terms of location, some jurisdictions provide their own values for example, for snow loads, and they're not referenced in the appendix. And so the only way that I can know to bring this into the calculator, absolutely people can send them to me if they want, and I can enter them in so that when they have if they're using the calculator, they can, at that very first page, they'll have their location and details on the drop down. But if you don't want to do that, if you want to do it yourself, you can come in here and create a custom location and add all these values in yourself. The values for the snow load, or the specified snow load, I think it's called, are calculated for you, but you'd basically be putting in, entering in here. So at the moment I've got a custom location. I don't know what city I'll use, but I know some places down, I think in the Kootenays use it. So let's say Kimberley, is that how you spell it? Yeah. And I think they use different snow values. So for mountainous regions, for example. So say we've got 2 ideas here. I've got no idea what the references are going to be, but it might be like 2.8, for example, and 0.4. Right. So once that information goes in, that was weird. Sorry. Oh, it did adjust. Okay. So once those numbers go in, we get values coming back here. I'm not sure of how you would determine these by jurisdiction. I'm not sure if that is appropriate or not. Now, there are certainly sort of references in the code where for areas where there is not an SMAX value, you can use the hazard calculation tool, I think it's in the MBC, and come up with these values specifically. And so you could input them into the calculator. And so then when we come back, we'll just use the snow load as the first example. when we come back to this works. Come back here. Right. If I type K, yeah. So all right, I'm going to have to look at that. Kind of embarrassing. I don't know why. Anyway, I'll look at that logic. It's certainly possible to do. I've just messed something up for sure. Anyway, all that idea's in there. A few more tables here related to the spacing of anchor bolts. Again, I've made some what I feel are conservative inferred references to these types here. The gypsum wallboard with two panels, one on each side. The thoughts being that, yeah, they're having to transfer a lateral load that is greater than their other namesake, and so the connection should theoretically be increased to accommodate for that. Again, just a bit of back-end calculation that pulls through to the construction reports, double top plate nailing. Anyway, people can look through this themselves a little bit. I'll probably lock off all of this stuff so there's no user entries required, but you can just review it all. I had some sort of thoughts and intentions about creating some visual representation of a design. I'm not sure if it's best to do this in Excel. For me personally, I think it would be awesome if there's a way to take the data of a lateral bracing design and turn it into something like what we receive as like an engineered truss package, where the trusses are visually represented, the nailing and connections are represented on it. And so with the data, at least in this calculator, we might be able to produce something like that. And again, for builders, that might be helpful. Certainly for building inspectors, that might be helpful as well. But anyway, that's sort of further down the line. And then there's just a few back-end items here that are largely undeveloped. But as you can see, it's still very much in a incomplete state. Most of the user inputs are functional. Yeah, I really appreciate you taking the time to watch, and hopefully you'll be able to get something out of this tool. And yeah, I look forward to hearing sort of the reports back on it, and look forward to putting that into action so that hopefully I can produce something that is helpful for industry. Anyway, I'll leave it for now. Thank you so much for listening. Take care.